When it comes to repeated elements, we have a unique way of treating them. So with repeated elements, if I have the word Mississippi, for example, Mississippi, there are 11 letters, and of the 11 letters, the letter I appears 4 times, the letter S appears 4 times, and the letter P appears 2 times. The letter M appears once. It's the odd man out. Now, if I had 11 unique letters for 11 spots in this word, I would have 11 factorial ways of organizing it. And the reason is factorial means 11 times 10 times 8 times 9 times 7 times 6 times 5 times 4 times 2 times 1. And that is the same thing we would get if we filled in bubbles from left to right for all 11 spots. We would go 11, 10, 9, all the way down to 1. So 11 factorial represents the permutation, the number of ways we could organize 11 unique letters in 11 spots. But these are not unique. We have repetition. And when we have repetition, what we do is we divide the original permutation by the number of times each element's repeated factorial. So we have 4 factorial for the I's times 4 factorial for the S's times 2 factorial for the P's. And if we were to solve this out, which we won't because it's a very large number, we would come up with a solution that gives the number of unique orders of letters that create unique words that we actually care about. And what it does is it removes the situation where we flip-flop these S's here, because changing these 2 S's in terms of order won't do anything. And flip-flopping these S's won't do anything, and vice versa here. And the same thing with flip-flopping these P's. We wouldn't create any unique words. It would still read from left to right, Mississippi. And by dividing by these factorials, we've removed those extra counts that we don't want to have. So let's look at our situation. We have how many unique numbers can be made by arranging the following set of integers. All right, well, in our set, we have 2 6s, we have 3 9s, and we have a total of 7 numbers. Well, if we had to use each of them once, then we would have 7 spots. So the 7 numbers in 7 spots would be 7 factorial. That's the permutation without worrying about the repetition. But if we have to get rid of the repetition, we then need to divide by 2 factorial times 3 factorial. And if you imagine the top of this, it's really 7 times 6 times 5, 4, 3, 2, 1. And on the bottom, we have 2 times 6, because 3 factorial is equal to 6. So 6's cancel, 2's cancel, and I end up with 3 times 4, which is 12, times 5, which is 60, times 7, 7 times 6 is 42, which gets me a total of 420. So 420 is our answer, and that is how we deal with repetition in permutations.